guess you could say we have mixed emotions about our traffic laws. And police radar is one of those subjects where you can hear the most interesting variety of wild and wonderful information that you can possibly imagine. If you're one of those people who drive around with tinfoil in your hubcaps to fool the radar, maybe you should stay with us for a few minutes. The word radar is a contraction of radio detecting and ranging. The type of radar that's used by airports and the weather office is really radar. Speed radar actually has nothing to do with that kind, and the term radar is more of a nickname. Speed radar uses a basic principle of physics that you're already familiar with, the Doppler effect. Here comes the demo. Now, when that car just passed, we heard the horn drop in pitch. Here's what happened. As the car was coming towards us, the sound waves from the horn were being compressed. The effect of that was to deliver us a higher frequency of sound waves than the horn actually emits. At the moment it passed and was going away from us, the sound waves were stretched out, delivering an apparently lower frequency. That's the classic demonstration of the Doppler effect. It was discovered in 1842 by Christian Johann Doppler. It would have been discovered even sooner, but Doppler had to wait for trains with whistles to be invented. And like any good scientist, Doppler confirmed his findings by hiring a train to drive back and forth, carrying a load of trumpet players. Trained musicians standing by the track were used to study the magnitude of the effect. The Doppler effect works with anything that exhibits wave motion, sound, light, and radio waves. This is what's in the unit that's pointed at the traffic. It emits very short wavelength radio waves. This particular one emits a radio frequency of about 10 billion cycles per second. These waves travel like all good radio waves at the speed of light. High-frequency radio waves travel a lot like light, and they're reflected in a similar fashion. At the same time the unit's transmitting, it's also receiving reflections from anything in its path: trees, billboards, moving vehicles, and even the road. Anything that moves is reflecting the signal at a slightly different frequency because of the Doppler effect. For this radar, that difference is only about 1,000 cycles per second at city traffic speeds. That's a small difference compared to the 10 billion cycles per second that left the antenna, but it's the basis of your speeding ticket. The electronics in the antenna unit subtracts the frequency that it sends out from the incoming radio signals and passes the difference on to the, computer. See, it is true that there can be a confusing array of difference frequencies from the antenna unit, particularly if the police car is moving as well as the traffic. Unfortunately for speeders, the computer has a wonderful ability to make sense of this mixture of whistles. Kind of like tuning a radio, the computer tunes up and down the band looking for strong signals and converting the strongest ones to useful data. The computer can figure out which whistles are coming from the moving patrol car and which are from the other vehicles, and because vehicles moving in the same direction as the patrol car appear to be so much slower than oncoming vehicles, you can sort that out as well. This differentiation isn't as tough as it sounds. This is what the mixture of outgoing and incoming radio beams sounds like. As the patrol car starts to move, the whistle starts out low and rises with the speed of the car. The computer tracks this whistle to keep track of the patrol speed. The high-pitched whistles are oncoming traffic, and the very low whistles are traffic going in the same direction. By keeping track of the patrol speed, this unit can display the speeds of vehicles going in either direction. Now, Acme hates to dispel myths, but there are a lot of them when it comes to Doppler radar. There's nothing you can do to a car to make this unit ineffective. The only thing you can do is slow down. This unit does not take a distance and time measurement, so slowing down after you see the patrol car won't help. The unit does require a decent speed differential to work. That's why the police often drive about 10 kilometers slower than the rest of the traffic. They don't just do that to watch all of the insecure drivers slow down too. An archaic law in the books requires the police officer to check the accuracy of the radar unit with a tuning fork. This comes from the old days of analog radars. The modern radars are more accurate than the tuning forks they're supposed to calibrate them. They use 2 quartz clocks, one checking the other, and if they can't display valid data, they blank their displays. As a matter of fact, at the factory, these radars are used to calibrate the tuning forks. Using a combination of proper radar techniques and proper police procedures, a radar confirms speeding tickets hard to beat. If you go to court and try to say that the officer dropped and nicked his tuning fork, you're only going to succeed in wasting everybody's time. Basically, when it comes to this unit, you're beat. On the other hand, given the congestion on the highways, maybe it's not such a bad idea to slow down.
Wow. It's crooked. I will fix it. Maybe I won't.
It took us a long time to get here. After 8 years of unsuccessful digging into tire manufacturing, around the world no less, we finally called Uniroyal Goodrich in Kitchener, Ontario. Sure, come on over, they said. Next time, we'll call them first. Tires are made from a blend of natural and synthetic rubbers. Not only are various ingredients combined to make individual types of rubber compounds, but several different types of rubber compound are used in concert to construct each tire. There's tread rubber, sidewall rubber, and so on. Each rubber compound is engineered at the molecular level to do a specific job. The raw ingredients are mixed in batches in a huge mixer called a Banbury mixer. From the Banbury, the different rubbers go to different locations throughout the plant. At this stage, all of the rubbers are very soft and sticky. There's an overpowering urge to grab some and chew on it. This is a cracker mill. The cracker mills squeeze air out of the rubber and allow the rubber to go around and around until it's completely uniform and needed for a process. As well, trimmed off bits of rubber are blended back into the mill. The sidewalls of the tires are being made here. The rubber is being warmed and squeezed through a die to create the shapes. This particular sidewall package is one that will eventually have white letters pressed in it. At the moment, the white strip is completely encapsulated in black rubber. The sidewalls are designed to be very flexible. These strips of rubber will become treads. Since different tires have slightly different recipes and dimensions, the pieces are all identified as to type. The treads are cut to an exact length. Then they have a carefully measured quantity of glue applied to the cut ends. These spools of wire are being grouped into a bundle, formed into a hoop, and coated with yet another rubber compound. The bead is the part of the tire that will be forced into the tire rim and form the tubeless tire seal. It needs to be very tough. The rubber-coated bead is given a cloth coating at this stage to further add to its strength. These large sheets of rubber are steel belt, single strands of steel wire coated with rubber. They're being cut and rejoined in a fashion that will make them end up like this in the final tire. A combination of steel wire belts under the tread and flexible polyester radial body plies class these tires as polysteel radial tires. By now, you may have decided not to try to make your own tires at home. This step should confirm your decision. This isn't the kind of job you get on your first day at the factory. Even though there are a lot of mechanical aids, tire building is quite an art. The first step is to install the beads. Then the various strips and sheets of rubber are all presented to the tire technician by a large robot. Focused electric eyes above shine alignment marks on the building drum as the tire is being built. This barrel is almost a finished tire. This operation rolls the barrel into something that looks more like a tire. The resulting donut is inflated and has its tread applied. Oh, doesn't look like a tread? It will. At this point, the tires have all of their rubber components and the beads in the correct locations, but the rubber is still soft and pliable, and it doesn't quite look like a tire. That's taken care of here. The secret to making the tire durable is the vulcanization process. The tires are vulcanized by heating both the outside and inside of the raw rubber tire at the same time. This creates new molecular links in the structure that make the rubber tough while retaining much of its elasticity. As well as performing the vulcanizing step, these molds contain the tread pattern for the tire and the lettering that will appear on the sides. It's called sidewall literature in the tire biz. Now it's a tire. The tires that come out of the mold could theoretically be installed directly on your car, but there are a couple of formalities. Here, the sidewall that has the white strip of embedded rubber is being ground down to reveal white lettering that was formed in the mold. Every tire is tested for roundness, smoothness, balance, and overall good looks. This is one of 2 Uniroyal Goodrich plants in Kitchener. This plant churns out about 3 million tires a year, all hand-built. These days, their entire operation is devoted to the production of radial-ply tires. Given the fact that no other manufacturer would let the Acme cam into their plants, we'd like to vote that these are the best tires we've ever seen manufactured. This is something every single family watching should have at least one of. The development of the under $20 smoke alarm is probably the biggest advance in home safety ever. The cheap smoke alarm is one of those rare cases where all sorts of 20th century blights have combined to make something useful and beneficial. Modern marketing normally attempts to create consumer fear about stupid things: normal body oil, the taste of cat food, the condition of your puppy's teeth, or wearing the wrong clothes. Using all of the same techniques, they managed to sell a lot of smoke alarms. And only by selling a lot of them, mass manufacturing, could the price come down. Modern electronics and manufacturing have given us greeting cards that sing, coffee pots that talk, and a reliable, sensitive smoke alarm. There are 2 main kinds of smoke alarm in the store: the photoelectric and the ionization. The photoelectric model has a chamber that contains a small beam of light, and smoke entering the compartment will scatter the beam a bit. The photoelectric type detect smoke particles, so a fire will be in its smoldering stage when the alarm sounds. Ionization detectors use a very tiny radioactive source. The source creates a stream of ions, which you remember from high school are electrically charged atoms. The ions allow a small current to flow in the detector. Smoke particles will stick to the ions by electrostatic attraction. You can study this by dropping some small pieces of paper in front of the television screen. The smoke particles interfere with the flow of current, and the resulting current drop can be detected. The ionization types are the cheapest and most sensitive kinds. They can detect a fire in its incipient stage, before there's actually any smoke. Gee, they're cheap and more sensitive. Why do you figure they make the other kind? Well, ionization detectors will also detect frying bacon and water vapor from the shower. The photoelectric types are better suited to locations near the kitchen and bathroom. Both detectors have the same considerations for mounting and maintenance. The units work by detecting smoke particles and combustion products in the air. In a heated house, air is constantly going up, so up is the proper place for them. The best location is in the center of the ceiling of a room or hall. See, there's a dead space for circulation near the walls. Both types will suffer from dust, either by giving false alarms or from reduced sensitivity. So include them in your vacuuming regime. The smoke alarm consists of a detector unit, either type, a noisemaker, a modern miracle microelectronic chip, a small light, and nowadays a 9-volt battery. Every one of these things is important. The basic function of the chip is to sense a small disruption in the detector's current, but they do more than that. As with all electronic things, mass production has made the electronics within smaller, cheaper, better. Here's a list of some of the tricks a modern smoke alarm chip can do. Directly drive an efficient piezoelectric horn. It's a cousin of the thing that makes greeting cards play music. The first alarms used inefficient bicycle horns, and the more efficient the noisemaker, the longer the unit can keep sounding the alarm. Go to sleep every 1.67 seconds to save battery drain. Wake up and check for smoke. If none, go to sleep for another 1.67 seconds. Test the battery every 40 seconds by applying a load to it. The only proper way to test a battery is under load, and that's what the little light is for. You might think it's only for you to assess the unit's operation, but it's also for the unit to test its own operation. In this unit, the light isn't even visible from the outside. If smoke's detected, it will increase its own sensitivity, sound the alarm, and continue to check for smoke every quarter of a second. The last critical component is the battery. Batteries provide electric current by chemistry. They become exhausted when the chemical reaction inside them is finished. The magnitude and duration of that reaction is different in batteries that use different materials. Never use a rechargeable battery in a smoke alarm. See, rechargeables go dead all by themselves, and they do it abruptly. The unit might not even have a chance to sound the battery alarm. For those people who weren't listening too closely, I have to repeat that. Never use a rechargeable battery in a smoke alarm. The battery to use is alkaline. Anybody's alkaline. They have the best shelf life and can sit around for a long time, then deliver a lot of current if they need to. Carbon batteries come packed with most alarms. They can give adequate service. But why would you want to save $1.50 a year on something as important as a smoke alarm battery? Well, make that $4.50 a year. You should probably have more than one smoke alarm. The instructions that are packaged with them give more information on location and numbers. And the local fire department will be happy to drop around and advise you. The sooner you can discover a fire, the easier their job. Even the latest in smoke alarms with a fresh alkaline battery is no good if the battery isn't installed. These things are designed to detect products of combustion, and there are several situations where they will trigger annoyingly. They're just doing their job. The best remedy is to avoid triggering them if you can, but if you feel that you must remove the battery for any reason, put it where you won't forget to replace it. On your toothbrush, for instance.